All right, we are live. Hello, everyone. Happy Tuesday. Very happy to be here with everyone this morning, evening, afternoon, wherever you are in the world. My name is Heather Grant. I'm one of the community admins here at the Maintenance Community by Upkeep. Thank you for making the time to join us for today's presentation. If you are not already a member of the Maintenance Community on Slack, we would love to have you join us. I will add the link to sign up in the chat in just a moment. Today we have James from Eruditio joining for a presentation on using asset criticality to move past squeaky wheel decision making. I'll let him introduce himself in just a moment, but I know we're in for a great presentation. The recording from our session today will be available right at this link after we end, as well as in the Maintenance Community on Slack tomorrow, along with a copy of the slides that you see here today. James is also available to answer any questions live in the Slack group, so please feel free to share either this recording of the webinar or the invitation to Slack directly with any friends, colleagues, or anyone else you know who would benefit from hearing James's expertise. Last piece of housekeeping, then we'll go ahead and get started. You'll notice that your cameras and microphones are not turned on today. So if you have any questions for James as we move throughout the presentation, or holding them for the end, feel free to do so as well. Please use the chat feature on the right-hand side of your screen to fire away, and we will leave some time at the end of our session for a Q&A. That is it for me, I think. Let me know if there's anything else in the chat, but thank you once again for joining us today. And James, I will turn it over to you.
All right, thank you, Heather. So good afternoon, morning, evening, everyone. Thank you for joining me today as we talk about asset criticality. All right, we're going to talk about how we use asset criticality to move past the squeaky wheel decision-making process. But before we jump into that, just a couple quick things. As we're going, if you have questions, comments, whatever, throw it in the chat or question box, and I'll be monitoring that as we're going through. So you don't have to wait till the end of the presentation for questions. Throw them in as they're coming up, and I'll be addressing them as we go. All right, and we'll try and keep this pretty interactive, pretty interesting, and like Heather said, if there's questions that come up afterwards or anything like that, feel free to reach out, LinkedIn, email, the Slack group, whatever you prefer, and we'll make sure to get those addressed. Now, some of you I may have joined on webinars in the past. Some of you I recognize some of the names from people I worked with, but for those that I have not, wanted to introduce myself quickly. So my name is James Kovacevic. I'm a principal instructor with Eruditio. So I've been with Eruditio about 4 years now. You know, at Eruditio, we're doing training, consulting, helping companies implement maintenance, reliability, and asset management programs. We are headquartered on the USS Yorktown, and we do work globally. Myself, I actually have spent about 15 years, give or take, in maintenance or in reliability and asset management. I've worked all over the globe, South America, Africa, Asia, Europe, as well as North America, implementing maintenance and reliability programs all over the place. I am Canadian, so if I say words a little funny, don't hold it against me. Aside from that, I have a weekly podcast rooted in reliability, comes out every Tuesday, where we bring on guests from all over the industry to talk about various topics within maintenance reliability. And on a personal side, I have 3 crazy kids, 2 crazy dogs, and a wife that puts up with all of it with me being on the road. So definitely always busy at home and while I'm away at work. All right, enough about me. Let's get into criticality. All right. So there's issues with decision making in most organizations I go to. There's really not a good process for decision making. Usually it's the squeaky wheel gets greased. Which operations manager is yelling the loudest? Which maintenance team leader is pushing that project through the most or being most vocal about it? It's really about who can speak louder, speak over other people, or it's really emotion driven. But we all know that that doesn't work within maintenance and reliability because we don't have unlimited resources. We have limited resources to really drive the organizational objectives and, you know, balancing the needs of operations, the needs of maintaining the equipment, that sort of thing. You know, decisions really need to be data driven. They need to support organizational objectives. One of the questions we should be asking ourselves as we're making decisions is, will this support the overall organizational objectives? Right? And then sometimes the decisions we make or are presented with can be in conflict with those. One of the greatest examples I can use for you guys is spare parts. Procurement has a goal to reduce the spend on spare parts. So they find these bearings that are a little bit cheaper. But what does that do long term? They may not last as long, and as a result, we spend more money overall in terms of downtime, repairs, etc. So we got to make sure that not only all the decisions we make leading towards the overall objectives, but they're not in competition with other objectives within that organization. And that's the next piece there. Lastly, we need to prioritize resource usage and figure out where are we really going to spend the time, effort, what work are we going to do first, that sort of thing. Now, the challenge is we don't have a lot of good decision-making frameworks that enable all these things to take place. All right, so we result to emotions and squeaky wheel. We're going to talk about how do we overcome some of that. And there's a couple different ways we can do it, but I think one of the most foundational elements is criticality. Now, there's other processes and systems, but criticality, I think, is a foundational element. It's relatively simply to use that we can incorporate into a lot of our other decision-making activities within the maintenance process, and we're going to get into that in a bit. But first, I got a little activity for you guys. All right, I want you to take a look at this vehicle here. All right, and what I want you to do is start thinking about this, and I want you to prioritize these 8 components or subsystems of this truck. All right, I want you to think about putting 1 on the most important, 8 on the least important. All right, I'm going to give you a minute or 2 to do that. Once you have that, throw it in the chat box. Just say windshields is number 1, air conditioning is number 8. Just give me the top and bottom one that you guys come up with and throw it in the chat box. I want to see what kind of results we get here. All right, so I'll give you a minute or 2 to do that. All right, I see people are typing already, so that is perfect. So there's no right or wrong answers, so don't worry about is this right, is this wrong? There's no right or wrong answers, all right? So if you think tires is number 1 and headlights is 8, whatever it is, throw that in there and we'll go through and take a quick look at this. Now there's a reason for this. As we're going through this, we want to understand the decision-making processes and perceptions that people have regarding assets. All right, I noticed on the people side here, we have a lot of reliability specialists, engineers, we got a couple supervisors, unit managers. You know, we have all these different roles here. We even see product managers and so on and so forth. And each one of these people is going to provide a different perspective. All right, so start looking at what we got here. So we have one person saying fuel pump is most important, air conditioning is least important. We got another person saying the brakes are most important. All right, we have another person saying by the looks of it, tires are most important. Then we got brakes again, followed by air conditioning at last. Windshield is 1, AC is last. AC is last again. We got brakes as number 1. All right, so you see here, we're starting to get all these different perceptions here. Brakes, then tires, headlights, windshield wipers, and so on and so forth. All right, so question for you guys as I'm looking at this. What is one of the most important things that your organization advocates for? I'm willing to bet it's safety. Right. If it's safety, why did no one pick seatbelts as the number 1 priority? Safety is the number 1 thing in most organizations. Why did no one pick seatbelts? And I'm going to hear a whole bunch of disagreements saying, well, if we don't have a fuel pump, it doesn't run, so we don't need seatbelts and so on and so forth. I agree 100%. That's our engineer brain going on. But organizationally, it's safety. All right, Hector, depends on where that truck is going to be used. That's exactly it. All right, so all of us have these different perceptions of what is more critical depending on where it's used, how it's used, and so on and so forth. And that is the challenge. You guys are recreating what happens in organizations every single day when we ask what is more important. Operations is going to say one thing. The engineers in us may say something else. The safety team's going to say something. The quality team's going to say something. We're going to get all these competing perceptions on what is most important. And that's where we resort to that squeaky wheel decision making. Right? So what we need to understand is, why do we get all these differences? Well, all of you have different experiences. According to Robert there, if I bought a Chevy, I wouldn't have to worry about this because it would just work. All right. So we have these different experiences. We have the different objectives. We have maintenance, engineering, production, quality, finance, all these competing objectives that we need to consider when we look at criticality. I think, Hector, you brought it up. Depends on where it's going to be used. 100%. For those of you that live in the country I live in, Canada, there is no way you're going to operate a vehicle without a windshield and windshield wipers in the middle of winter. You're not going to see anything. Those are critical. But if I were to tell you that you were just operating this vehicle in the plant yard only during daytime, okay, now we might not need headlights. If it's in the desert, well, we might not need windshield wipers now either. That operating context plays a huge piece of it. And then we have the different priorities within all the groups that we need to focus on. So how do we overcome this? We overcome it through a criticality analysis. And all these things are why stakeholders never agree on what is most important in the plant, because everyone has these different experiences, objectives, and so on and so forth. Criticality helps us overcome that. Right. There's a few other things too with criticality that I want to chat about before we get into the nitty-gritty of setting it up. In our experience, criticality is one of those fundamental elements that if you don't get right, you're going to struggle with the rest of your maintenance program. So if we take a quick look at what we consider the elements behind a maintenance program, you're going to see at the very top we have an asset catalog. We got to understand what assets do we have. Then we're going to do some statistical analysis, and we're going to get into asset criticality analysis. Now that drives decision making throughout the rest of the program. It's going to determine where are we going to take the time to do a failure mode analysis, whether it's FMEAs, RCMs, a type of PM optimization, that sort of thing. It's going to help us make decisions on where we invest time and effort in the bill of materials. It's going to help us make decisions on how do we manage this unplanned work or this breakdown work? How do we prioritize that? It's also going to help us drive which bad actors do we address. We don't have resources to address all the bad actors, so which ones are most important? It's going to help us with all those different elements. It's a foundational element, and if we don't get this right, the rest of our program is going to struggle. Unfortunately, most organizations look at this after the fact. All right. So the first thing we got to do for asset criticality is understand what assets we have, and then determine what level are we doing criticality. Now, normally I'm going to advocate for level 6 here, the equipment unit. All right, so if I have a pump, a compressor, and so on and so forth, that's where I want to see it long term. Now, if you're limited on resources and don't have good data, or people aren't willing to invest the time yet because they really don't know what this is, you can start at the system or section, and then which ones of those are critical, then go in after the equipment underneath there. Kind of prioritize where you're going to focus first, doing it that way. But I really think you need to go to the equipment level, because that's where we're making decisions. We're acting on the equipment. All right. Now, from there, now we know where we're doing criticality. We have our equipment that we're going to do it on. We've got to make sure that criticality gives us the right level of resolution, if you will. All right. There's a challenge with criticality. You often see a lot of organizations, when they plot it out on histogram, they get these nice bell curves and they get a skew right, skew left, all these different things. But is that the right distribution that we have or we need as an organization to make decisions? Remember, criticality is there to allow us and enable us to make more informed decisions. All right, keep that in mind as we go through this. So the reason I say that is because if all 5 assets or 10 assets have the same ranking, which one takes precedent? You get into the arguments then within the organization that this A is more critical than that A, which is more critical than that A. And we get back into the same squeaky wheel decision-making process that we have been in. So we have to make sure we provide enough resolution within our criticality analysis to provide objective decision-making. So how do we do that? Well, we have to ensure we have the right distribution. So before we get into what is the right distribution, let's talk about some of the common distributions we see with criticality. So first, we might see a normally distributed criticality analysis. So this is a summary of all of our assets that we ran analysis on. You can see we got a little bit of low criticality assets, a few high criticality assets, but most of them are kind of in that middle. All right. What do you guys think? Is this good or bad? Is this what we're striving to achieve with criticality analysis? Okay, we got a no. All right, we got a few more no's coming in, so that's good to see. All right, I would agree. This is not really where we want to be. So let's talk about the good in here. Well, the good thing with this distribution is we use the entire range. All right, so that is a plus. The bad, strong central tendency, little to no resolution for over 80% of the group, meaning 80% of the assets are really going to have the same criticality ranking, so we can't make decisions about it. All right. So our assessment in this is if we saw an asset criticality done this way, not the right distribution. Go back to the drawing board. Here, we got bimodal. All right. So the good here, we use the entire range, a little bit better than that normally distributed distribution we saw previously. The bad, two major central tendencies. It's either critical or it's not critical. All right. That's what this is showing us. There's really nothing in the middle there. All right, so our assessment, not a good distribution again. All right, right-tailed. All right, good. Use the entire range. Strong central tendency to the left. Essentially, this tells us nothing is critical. All right, that's what it's telling us. Really, nothing is critical. So it's pretty easy. We're just going to focus on those 4 or 5 assets over there on the over there, and that's all we're going to worry about. Poor distribution. All right, left-tailed. Use the entire range. Once again, benefit, bad, strong tendency to the right. Essentially, everything is critical, so nothing is critical. That old adage comes into play. As a result, once again, this is a poor distribution. And right short, there's nothing good about this one. We don't even use the entire range. Here, nothing is critical. Virtually useless criticality analysis in our opinion. All right, terrible distribution. Don't want to do that. So how do we get the right distributions for our analysis? Well, there's a couple of techniques you guys can use, and we'll explore a few of them. The first one that we like to talk about is looking at the minimum number of factors we need to include in our criticality analysis. And this is really using the square root of the size of the data set. So for example, if I have 10,000 assets, how many factors do I need? Well, let's shrink it down and make math easy. If I have 100 assets, all right, there's my data set, 100 assets. How many categories or scales within those categories do I need? Well, the square root of 100 is 10, all right? So therefore, I need to have 5 categories with a scale of 1 or 2 categories with a scale of 1 to 5. That should give us enough resolution for having a properly distributed asset criticality analysis. So as an example here, we got 10,000 assets. We need 100 steps of resolution. Therefore, we may have 20 categories. We may have a category on impact on product quality, impact on regulatory, safety, spare parts, and so on and so forth. And we'll get into those categories in a bit, but we'll have about 20 of those categories. And each one of those categories is going to have a scale of 1 to 5. With all those answers, that should give us enough distribution to have a meaningful analysis. All right, so let's explore this a little bit further. Now, some of the evaluation criteria, those categories that we have defined, mandatory, we want to see what is the operational impact to the asset. What is the safety impact to that asset, the environmental impact, and the quality impact to that asset? Right? Those are the 4 minimum we typically want to see within an organization. Now, depending upon your organization, there may be more that you need to add. Now, I don't suggest you have to do every one of these, but you have to figure out what is important to your stakeholders and incorporate those. One of them might be maintainability. How easy is it to maintain this asset? If it's very difficult, that may drive it up in criticality because when it fails, we know it's going to be down for a long time. How easy is it to access? Whether it's for planned downtime, that sort of thing. Do we get regular planned downtime on it? If we don't, then that may drive up criticality because we're not able to do the maintenance we want to do on it. Spare parts availability or lead time may be a factor. If we know that we're getting these parts from overseas, extended lead times, that may drive up criticality as well. Is there a redundancy or contingency plan? So is it a single point of failure? Is there a workaround that we can put in place that would allow us to still enable the output of the process or equipment in the event of a failure? If we have that, might have low criticality on that ranking. Replacement cost. Are we spending a lot in terms of maintenance dollars per capital asset replacement value? If it's a high cost to maintain it, it's a little bit more critical. We probably got to put a little bit more effort on it. Is it getting up in age? What's our MTTR, MTBF? These are all different factors that we can use to help set up those categories of evaluation. Right now, there's plenty more on here that you can include. There's stuff I've seen around organizations where food safety is an issue, so they put that up there. There might be other operational impacts that they may have, or cost impacts that they may have. You can put all the different categories you want. Right, but the starting point, the square root number of assets, gives us that kind of scale we need, and from there, number of categories, we can determine what is the ranking for each one. Now, as an example, you may see something like this, where we have safety consequences from a 0 to 4, environmental consequences, manufacturing, quality or scrap costs, maintainability, and accessibility to execute that planned work. All right, so here's one example that you may use, and now we can evaluate our assets against each one of these categories. So we got the 5 categories there, and then we have the scale we're going to address against. Right now, in the end, it's going to look something like this. Now, these are just a couple examples, but you can see in the first, or in the top one there, we rank our assets. Then we look at our operational severity. In this case, these two get a ranking of 100. This one here gets 20. Then for safety, we may have multiple categories. Here, personal injury. Is there a risk of personnel injury when that equipment fails? Is there a risk of fire explosion? Or is there an increased risk of safety while doing maintenance? Then here, is there a risk to air emissions or chemical spills? Is it a single point of failure, meaning we're going to shut down a line, a section of the plant, the entire plant, so on and so forth? Maintainability, failure rate, spares lead time. We go ahead, and in this case, we're going to add those up and get our asset criticality number. This one over here, you can see we have all these different categories again: customer, capacity, what's our PM cost, our corrective maintenance cost, our cost against replacement asset value. Is there an EH&S risk? What's the MTBF? What's our planned utilization rate? If we're only going to use this thing 10% of the time or 90% of the time, that may factor into it. You got a single point of failure ranking and then a spares lead time. And you're going to decide for each one of the assets against these rankings here and assign those numbers. Right? Now, if we do this correctly, we should get a different type of distribution. Right? One of the distributions that we should see is something like this. There's not going to be a mode. All right, it's going to look completely random, if we will. All right, so in this case, we use the entire scale, no defined mode. There's really nothing bad about this distribution. This is the preferred one that we want to see. So here, yeah, we may have some assets that share the same, fall into the same bucket between 20 and 30 or between 80 and 90, but they're distributed enough where we can generally make good decisions without a lot of effort. All right. Now, we've worked with some organizations where, this, based on some of their criteria, whether it was food safety, whether it was risk to regulatory requirements, those things kind of trumped. And with multipliers and that, they kind of took over the criticality. So they had to approach this and actually scale it out a little bit more. So that will happen depending upon your organization and those types of things. But the square root of number of assets is a good place to start. Right? So with that being said, what do we do with criticality? There's a couple things that we're going to do with the criticality once we've actually gone through and ranked it for this as part of the analysis. Okay. Here's an example of a phosphate mine that we have worked with in the past. You can see how their assets were distributed over the criticality ranking, and you can see we have these red lines here. Right? So these red lines then bucket our equipment for simplicity in coming up with equipment strategy techniques. So here you see the top criticality equipment over here at the ranking of 500 to 400 roughly. These we would consider our most critical assets. How we manage these assets are going to be different than how we manage these next bucket versus how we manage this next bucket and what we do at this last bucket over here. So we're going to use their individual criticality ranking numbers and a variety of decision-making techniques that we'll talk about in a few minutes. But we're also going to make some general strategy determinations based on what bucket they fall in. So often you'll see organizations will say the top 20% of assets or top 10% of assets fall in this bucket. And that's where they're going to do FMEAs, RCM, that type of thing. This last bucket here, compliance or run to failure. And that's where they kind of stick those at. But we'll talk about that in a few minutes. Once you've done that analysis, you have to ask the team, does this make sense? Does this align with gut feelings? If so, why or why not? Sometimes, our gut feelings tell us that this criticality, it's off. Maybe something's weighted too heavy. Maybe there's too much emphasis on one or two categories and it's throwing the whole thing off. Or it may align and we're getting kind of what we thought we were going to get as a result of it. All right, so we want to do that gut check. Then we want to ask ourselves, once we plot it, do we get enough resolution so it's going to enable good decision making? Key here is, if it doesn't provide enough resolution, if the gut feeling isn't right, don't be afraid to go back and revisit, revise that criteria and ranking, and scale up if needed, if the assets are all bunched up. All right, so one of the clients we worked with, they revisited this 3 or 4 different times till it got right for their assets, their criteria, all those different things. So when you're doing this, you generally want to do it on a trial, pick 100 or 200 random assets, do your first criticality analysis on that, make sure it makes sense, then scale it out to the rest of the organization. You don't want to do all your assets, then realize this doesn't feel right, it doesn't look right, that type of thing, it's not enough resolution. Do a little bit, go back, revisit, and so on and so forth. All right. Now that we've got criticality, what do we do about it? All right. So the first thing we got to do is we got to get it into the EAM or CMMS. All right. Not every CMMS is set up so we have an actual number we can put in. Sometimes it's, we can have a 1, 2, 3, 4, 5 scale. We can have an A, B, C, D, E scale. We can have those sorts of things. If that's what we have to start, use that based on the buckets that we talked about earlier. But we want the actual criticality number, that RPN, incorporated into the CMMS somewhere. Sometimes I see it in attribute fields. Sometimes I see other fields repurposed for it. But we want that specific number because that's going to help us with work management and a very few other things afterwards. Once we have that all in the system, then we want to use criticality to eliminate that squeaky wheel decision making. We want to move towards using it to make informed decisions. Those informed decisions are going to be in the equipment strategy. How do we manage these assets? Work prioritization, spare parts planning, then RCA and continuous improvement activities. That criticality is going to factor into all these different things. So let's talk about equipment strategy. Now, normally what we'll say is that top 20% of those assets, sometimes top 10, depending on resources within your organization, those are the assets we're going to invest heavily on doing an FMEA, an RCM analysis to really decide what do we want to do about this asset to maintain it. Right. So we're going to invest the resources where it's most critical to the business. That next bucket, 21 to 40% of our assets, we're going to put them through a PM optimization analysis or a maintenance task analysis or something to really clean up what we already have to make sure it's effective, identify any low-hanging fruit that we're missing through our equipment strategy program and get those enabled through there. Some organizations may scale these differently. They may say top 10% for FMEA, RCA. That next bucket might be from 11 to 50% goes through PMO. Others may go 21 through 60. That's up for you guys to kind of figure out how many resources do we have, how do we want to manage our assets. That last bucket might be OEM recommendations followed by run to failure except for our regulatory requirements. So every time we create those red lines in that phosphate mine example, we create those larger buckets to manage these different assets here or manage them differently. It will also help us prioritize CapEx for system or assets that need to be redesigned, replaced, upgraded, so on and so forth. If it is a very low criticality asset, why would we invest time and effort in CapEx? We want to focus on the ones that have the impact on the business. Also, if we're just getting into PDM and we're looking at deploying predictive maintenance, online monitoring, those types of things, this may help us to understand where we best to put it. We're not going to invest all this time and effort on low criticality assets. It should be the higher criticality assets combined with an FMEA or RCM analysis, right? So this should really guide what are we going to do to maintain our assets. The other stuff is it's going to help us with work management and work prioritization, right? Oftentimes you hear arguments over and over and over about what work do we schedule first. Well, if we use the RHYME method here, you can see that we have criticality down here on the left-hand side, and we have numbers of 1 to 10. Now, this might be the different categories you have. Other organizations don't lump it into buckets. They use the actual RPN from the criticality analysis. So if that asset has a criticality of 392, then that's what they're going to put there. Then you have the different type of work spread across the top. So we might have environmental health, safety, or breakdowns, might have product or quality loss issues, and so on and so forth. So this way we can scale the type of work against the criticality asset and determine which work are we going to do first, right? This allows us to focus on the most important work to the business first, right? Now we use this in addition, this method here, for breakdowns and unscheduled work. If it is a major piece of production equipment and it's going to impact overall or the site and it's a breakdown, okay, so it might be a 80 or 90. However, if it's a facilities equipment or non-production limiting equipment and we're just doing some capital work, that's going to be down here at 9, and we're not going to focus on that right away. For backlog management, we want to tackle the largest or the highest numbers first, right, and work our way backwards. And then at the scheduling meeting, when we have all of our production and operations stakeholders in the room, we have some of our maintenance stakeholders, engineering, and so on and so forth, we can use this to prioritize what work we're going to do next week. All right, and if there's disagreements of upcoming work or found work that we have to address in a quicker period of time, which work is going to take up that last 10 or 20% that we haven't scheduled yet within our work management process. All right, so we're going to use that to help drive these decision making. Now, I will say there is a downside to this method here for the work prioritization piece involving criticality. And that is some of this lower criticality work may never ever get done. It's low priority or low criticality equipment, low priority type work. It's going to sit down here in the bottom. We may never actually get it. So one of the things we're going to advocate is if you're using a system like this, you want to add one additional thing, an age factor from your work orders. So for example, if my work order is less than 30 days old or less than 60 days old, I'm going to give whatever this number is a multiplier of 1. If it's between 60 and 90, I may give it a multiplier of 2. 90 to 120, it might get a multiplier of 5, and so on and so forth. So eventually, even this low criticality work will eventually move its way up. Now you can scale that however you wish, but there should be something in here to address the age of the work to drive it up over time. That way, we're not ignoring the low criticality work. We're just going to take a little bit longer to get to it, if you will. All right, spare parts. Criticality plays a big role in spare parts. We want to understand which assets are a single point of failure with a large impact on the site output. Those are spare parts we probably want to stock or at least evaluate for stocking for those assets. Doesn't mean we're going to stock them. If we can get them in a day and they fail once every 5 years, we're probably not going to stock them. But if they're a 10 or 15 week lead time, and even though we only use them periodically, we may stock those. All right, so we're going to use our criticality metrics to drive that decision-making process. Some organizations that we work with, they look at the consequence or impact to site, the usage rate, and the lead time of the part. And those are the 3 things that they choose to use for evaluating, do we stock those parts? Now, if you don't have consequences for those individual failures, a lot of organizations substitute asset criticality for that. So you take asset criticality, evaluate it with usage and lead times, and that will help you determine, do we stock this part or not? If the sites don't, or if the assets don't have an impact to site output and there's no risk of health and safety or anything like that, then those are spares we're going to want to evaluate for reduction in stock levels, or order on demand only. The criticality piece here is really to help us decide, where do we focus our time and effort for spare parts again. Then lastly, we have root cause analysis. Now, if it's not an important asset, save the resources for an RCA on an important asset. We don't have unlimited resources to do root cause analysis. We don't have the time, training, effort to do that. So let's prioritize our RCAs based on criticality. What we normally see, if it's above a certain threshold number, so it might be a top 50%, top 40%, etc., those are the ones we're going to do criticality on, or RCA on. If it's below that, we're not going to invest the time and effort right now because it's not important enough to the organization. We got bigger fish to fry, if you will. It can also be used to help prioritize the RCA actions, training, SOP development, CapEx deployment, all those different things. Criticality can help us prioritize against all the other things going on. So if we have actions from about 40 different RCAs to do, and we have limited money, limited time to develop SOPs, or limited training budget, let's focus on the activities that are going to impact the highest criticality assets. Right? That's what we're really looking at, is how do we drive that decision, or drive the decision making to the biggest impact on the site. Now, some of the questions I routinely get about asset criticality is really, who does it? All right, so if I go back here for a second and we look at doing this analysis, establishing the categories, the scale, all right, determining which ones of these we're going to use, and then actually ranking the assets. Who does that? What do you guys think? Now, normally, all divisions, I like it, an asset manager. So I believe RE, manager, supervisor. All right. So what I generally like to see is that asset manager, that reliability engineer, that manager, they might be the one that's responsible for developing this process. They're the owner of it, if you will. But all divisions need to be involved in the analysis and selection. If I just leave it to the reliability engineer and they're the ones who determine what this evaluation criteria is, we have a problem. And that is that maintenance decided what this criteria was. They decided on the scale for each one of them. And that means nothing to me as an operations person. So you want to have a reliability engineer, an asset manager be responsible for the process, but you have to get all those different divisions, quality, risk, EH&S, operations, involved in selecting these categories and then helping to shape the ranking criteria for their respective categories. All right, so quality is going to have a big input to what is a 1 to 10 scale for quality. Environmental will do the same thing for theirs, and so on and so forth. Then once we have all that defined, then we're going to get people involved from those respective areas to help evaluate all this. Some of this criteria here, we may have good data, and it's going to be pretty easy. MTTR, MTPF, asset age, stuff like that, we'll probably be able to pull a lot of that out of our CMMS or EAM, and that will be pretty easy to evaluate. Other things, we may not have that information in a CMMS. So the redundancy or contingency plan, that might be something that operations, maintenance, engineering, EH&S, or risk are going to talk about and say, you know what, we do have a workaround. It's kind of manual, so that's going to be maybe a 6. Other instances, they might be like, oh, there's a standby system right next to it. We just flip it over. It's automatic. It goes. And that's a 1. You're going to have conversations with the other team to make sure they're fully aligned. Now, it does slow down the process a bit, but here's the critical piece. If you do not have all of those divisions involved in this analysis, setting up the criteria, the scales, and then evaluating the equipment, The challenge becomes it's a maintenance thing. It's not a site thing. It's not an organizational thing. And as a result, it's going to be ignored when it comes to decision making. So if you want this to be used to drive data-driven decisions and get the organization aligned with it, your ops team, your quality team, etc., they have to be involved in the process. If you don't do that, it's going to be relegated to just a maintenance thing that no one uses, and it'll quickly fade away. All right. So that's one of the big things you really got to watch out for. You got to pick your right team, make sure it's cross-functional, and evaluate that way. All right. How often should criticality be run? Okay, Hector, great question. So when we review this, there's going to be a couple of different points that I would say you want to review this. Right? If there's a significant change to the operating context of the plant. So if we went from, say, for example, 24/5 operation to 24/7, we may want to reevaluate our criticality. If we've added new production lines, we may want to reevaluate criticality for those new production lines. So as things change within your organization, we want to evaluate that for new assets, changes in operating context, that type of thing, and use those as triggers to drive a review. Now, barring that, I would say at minimum every 2 to 3 years you want to go through and review it. All right. Now, in that instance, though, I've also heard concerns from clients and others that are very well based is, our product mix changes at the time of year. So what certain lines that are important in the first half of the year become less important later in the year, and other ones that were less important become more important. If that's the case, then you may want to do it twice a year to reevaluate what the impact is on the business for those seasonal type products. So you want to take that into consideration as well. All right, question here from Ricardo. It seems like redundancy, contingency plans, spare parts are mitigation strategies for high criticality asset. Should mitigation strategies be part of assigning a criticality number, or should those be considered after criticality? All right, so those mitigation strategies should be evaluated after we assign a criticality number. Reason being is we don't want to assign these different things if it's a low criticality asset. So do your criticality analysis, then implement your mitigation strategies for those high risk assets. All right, so with that being said, there are some extra resources on criticality I'll point you to. All right, and I'll open it up for questions. Sorry, one more thing, then we'll do that. So getting started with criticality. A couple of key things you guys need to do as you go to implement criticality to move past the squeaky wheel decision-making process is first define your key stakeholders. All right, who's the operations, quality, and so on and so forth people I need to have involved in this process. Then determining where you're measuring the impact of loss on the system or system function. So for example, are we looking at product out of the door? Are we looking at number of cases filled, or figure out what that production or operational impact is, so we're measuring it the same across all of our assets. Then we develop that list of criteria that will produce that granular ranking, right? Develop the criticality matrix and a template to record your answers. So if you need some of these templates, let me know. I'll be more than happy to share some out. We have about 3 or 4 different examples we can share to show you how others have done it. You're going to have to refine it to your own organization though. From there, you may define the system or group of assets to be evaluated first. Remember, we want to make sure this is going to work. So just do a group first. Then once it's proved out, move on to the rest of your assets. Want to select the team of SMEs that will be able to answer the questions in the analysis honestly. So this goes back to having all divisions or all functions there. You may have a senior operations manager helping define that criteria, but then the operational representative during the analysis might be an operations supervisor or team leader, because they have a better understanding of that equipment. All right, so you may want to change who's present for some of those analysis based on what equipment you're talking about. You want to schedule a meeting, gather all those SMEs, and begin the analysis by asking the questions on the impact of the factor based on the criteria selected. All right, key thing here, even if we have those categories defined, operational impact, maintainability, so on and so forth. We need those scales defined. What does a 1 mean? What does a 2 mean? A 3 mean? And so on and so forth. We want defined criteria there. Or once again, we move back to a very subjective analysis and people begin to argue about what's a 1, what's a 2, and so on and so forth. So you want defined scales there. From there, once we've done that, we've determined what it is, we're going to record those into the template. Then we're going to rank the systems from high to low value, and then we're going to start working on those higher criticality assets. All right. Some organizations have taken it to the point where they're not only doing their equipment strategy, but they're also looking at what are the common tasks we perform on these assets. Maybe it's alignment, maybe it's bearing installation, and so on and so forth. And then they start creating SOPs for those specific tasks so they can reduce the risk of infant mortality, failure, those types of things on those assets. Right? But the key here is, regardless of where your focus is, act on the analysis. If you do the analysis, load it up in the CMMS, and you don't do anything with it, it's a waste of everyone's time. All right? So the key here is when you're done with it, you actually got to use it. That's why it's so important to get that cross-functional team or all the divisions in that selection of the criteria, the scale, and the analysis itself. All right. Any questions on criticality? Using it, developing it, deploying it, anything like that, feel free to throw it into the chat or question period. While you guys are doing that, there are a couple asset criticality resources here you guys can access. So we have a few podcasts on this topic. We have one with Susan Greenman, Risk-Based Asset Criticality, so you can access that there. We also have one with Susan LaBelle, who I saw on the podcast. I don't know if she's still on or on the webinar, but I had her on to talk about asset criticality as well. So you can catch that there through that link. And then there's another podcast that I did myself earlier on. From there, there's also a couple blogs there about it that dives into the details there. Those are some resources you guys can access if you want to dive into criticality and get a couple different perspectives as well on criticality. All right, Susan, I'm glad you liked the square root of number of assets. I don't know if you'd find that in a book. It's just something we learned a while ago through experience. But many organizations start to use that as a starting point, and they may scale it accordingly. All right. Another question. We're beginning the development of our criticality process. What are some ways to ensure we get value if we start at the system level than the asset level? All right, Ricardo, great question. The reason why we may do it at a system level, then break it down into the asset level, is just because of limited resources. What I see some organizations do is they'll evaluate their systems. Once they've established that these are the top 2 systems or top 3 systems, then they deep dive those systems into the criticality analysis at the asset level. All right, so they don't do all of the assets. They start with the system, and then they break those more important systems down into the asset and target those there. So hopefully that answers your question.
All right. I see we have someone typing. We'll give them just a minute in case it's a question. But thank you so much, James, for running through all of that, as well as some helpful resources at the end there. It's really appreciated. I know by myself, and I'm sure by everyone on this call as well. If you do have any follow-up questions for James, please feel free to reach out to him via email, Slack, LinkedIn, I mentioned earlier, or if you want any of those templates that he's mentioned as well. I know those are always a great resource. I think that's all from me. Any final thoughts, anything else to add?
No, the only thing I'll say is just what you said, if you have any questions, concerns, whatever, feel free to reach out. My contact information is on the screen. Call, text, email, LinkedIn, Slack group, whatever works for you guys, reach out. Be more than happy to get you guys templates, examples, or if you want to just talk about criticality and how it fits into your organization, I'd be more than happy to do that as well.
Awesome. Thank you once again, and I will see everyone soon. Have a great rest of your day.
All right, thanks.
Thanks.